Hi, everybody. Thank you so much for joining us for yet again another webinar here. We're excited about part 3 of our marine megafauna series, The Big Fish. We do have a lot in store for you today, including some tuna fish prints, which we'll be showing you how to do at the end of this broadcast. I will ask if you have any questions to please hold them to the end. We will have a Q&A. If you have to leave for some reason, please feel free to shoot us an email or ask a question on our Facebook page. Be more than happy to answer those for you. If this is your first time joining us, Ocean Protection Advocacy Kids is our name. We like to call ourselves OPAC for short. We teach K through 12 marine science, art, and advocacy workshops across Massachusetts. We are headquartered in Plymouth. And unlike a lot of marine science organizations, we are heavily dependent on art and advocacy. So every marine science project, or every marine science lesson we do has an art component to it. Today, that will be our fish prints, and we're really excited about those. Like I said, we have a lot in store. We're going to define what is a fish. We're going to look at some adaptations that fish have. Explore a couple of my favorite fish species, and then we're gonna see why fish are so important to us as humans, and then we're gonna show you how to do those fish prints, and we'll have a little bit of time for a Q&A at the end. Thank you so much for all of your support over the past few weeks, and we look forward to continuing to offer all of these virtual experiences over the next few weeks as well. All right. So I just want to recap on what we mean by marine megafauna, since that is the name of this series. These are our very large creatures in the ocean. These can be seals, pinnipeds, whales, sharks, the big fish, like we're going to talk about today. But these can also be turtles and manatees, giant manta rays. They don't have to be marine mammals. So I just want to do a little recap on what a fish is and some fish adaptations before we look at different species. A fish is a vertebrate, so it has a backbone. They're vertebrae that live in the water, that can be freshwater or saltwater. They use gills to breathe and fins to swim. So unlike the first two parts of a marine megafauna series, where we were looking at marine mammals that had to come out of the water to breathe, our fish do not. Most fish have scales that cover their body, but not all do. And some have scales at different parts of their life cycle. Nearly half of all of the vertebrates on our planet are fish. There are predictions that there are between around 20 and 30,000 different species of fish around the world. And again, about half of the fish species cover the vertebrates on our planet. So there are, if you add up all the mammals and birds and reptiles and amphibians, the other vertebrates on the planet, they only account for about the other half of vertebrates. So there are a lot of different fish. We classify them into 3 big groups. The jawless fish, which we're not going to talk about today, but these are very primitive fish. These are fish with no scales and no jaws, obviously. This would include the families of hagfish, which look like big slimy worms or eels, and the lampreys, which are pretty cool. They use their mouths as like suction cups to get their food. Again, they don't have a jaw. They do have teeth, but they don't have a jaw. And we have the cartilage fish. These are our sharks and rays and skates. And then we have the bony fish, which account for about 95% of all the fish in our ocean, both freshwater and saltwater. When you say fish, this is usually what people are referring to. So your salmon, your tuna, your goldfish, they're all in this category. Fish have many different adaptations that help them survive in the water. An adaptation is something unique that an animal has that helps them survive in their habitat. So our marine mammals had unique adaptations to help them survive in their habitats, and fish have the same. The big one being gills. Gills allow fish to breathe underwater. They still need oxygen in their blood to survive, just like we do. So fish will inhale that oxygen-rich water. That water will go through the gills, supply oxygen to the blood, and then the fish will exhale that water, which will also push the carbon dioxide that is the byproduct of respiration or breathing and push that out of the fish. This is a pretty complicated process, which I just want to put up there. We're not going to go into the details, but if you'd like to learn a little bit more about how gills work, there is a lot of information on the internet. Another adaptation that fish have are fins. Fins help fish swim. So again, it's a body part that helps them move through the water. We have dorsal fins, which are on the top of our fish or the animal. Caudal fins, which are the tail fins, so they're at the back end of our fish. Pectoral fins are on the belly or the bottom, the underside of the fish. They're usually closer to the head. And then we have the pelvic fins, which are also on the underside of our fish, but they're located closer to the tail. And then another great adaptation for fish is the swim bladder. The swim bladder is what keeps our fish buoyant. So, you know, fish still have to float and stay within the water column. And this is just a sac within the fish that allows them to control their buoyancy in the water column. So we have the gills, which are near the head. Again, that's going to let oxygen-rich water into the fish. We have barbels, which is another ocean adaptation for fish, which are kind of like our nose. They help fish like catfish in murky water find their food source. Counter shading is really important for many fish species. Counter shading is like camouflage. So a lot of fish have white bellies or lighter toned bellies, so that if you were underneath the fish and you were looking up in the water column, it would look like the sky. And vice versa, the fish are usually darker on the top. So if you were looking down into the water, it would also blend in with the water. So this is counter shading is camouflage. And then we have the fins that we talked about. The dorsal fin on top, our pectoral and pelvic fins on the bottom, and our caudal fin on the back. The other thing on here that I thought would be worth mentioning is the lateral line. The lateral line of a fish is like a sensory organ that helps them feel what's around them, so they can sense if there's other fish or currents near them that they need to go towards or avoid. All right, so now that we know a little bit about the anatomy and adaptations of our fish, we're going to start with one of our cartilage fish, the biggest fish in the ocean, the whale shark. It is a shark. It is not a whale. It has the name whale because of its giant size. Whale sharks are usually about 20 to 40 feet big. They are really large. There was a whale shark accidentally caught in the early 80s, and it actually weighed in close to 40,000 pounds, or sorry, 24,000 pounds and 40 feet in length. So they are massive fish. They actually do have some of those barbels that we just looked at near their eyes and their nose that help them smell through the water column. Whale sharks have very small eyes, and they are filter feeders. So even though they are really large fish, they're actually not aggressive at all. As you can see in the picture here, divers can get very close to them. They're a big part of tourism in some areas to go swimming with whale sharks. And again, they are filter feeders. They can do this passively by just opening their mouth while they're swimming, but they can also do this a little more actively by taking gulps of water and expelling that through their something called a gill raker, which is similar to the process of which our baleen whales that we learned about last week do for feeding. So the whale shark, again, can feed passively or actively, but they are primarily eating our zooplankton. They're filtering food However, they do eat sea jellies and some crustaceans and squid as well. Their mouth is really big. It's the whole length of their head. It can be about 1.5 meters wide, close to 5 feet. And it's kind of cool. Some things that we can see on them are those wonderful white spots. Like our whales that we learned about last week, these spots are thought to be ways that we can ID whale sharks. So they've observed many individuals in different populations by taking pictures of the whale shark and seeing the differences in size and location of the spots on the whale. And they also have 3 prominent ridges that we can use to identify the species, which you can see here on the picture going down the side of the fish. My next fish here is one of my favorite fish, the ocean sunfish, or Mola. We are going to concentrate on just Mola. There are a few other species of ocean sunfish, but the Mola is the most prominent, and it's the one that we know the most about. And they are found pretty much all around the globe in temperate waters. Mola is Latin for millstone, which is another large, round, gray, rough object. But the common name of our sunfish the common name of the Mola is the sunfish, and it gets that name because it comes up to the surface quite often, both to warm and to clean itself from parasites, which we're going to talk about more in a moment here. The Mola is the largest bony fish. So the whale shark often gets all of the credit for being the largest fish in the ocean, but it is a cartilage fish. The ocean sunfish is a bony fish. The largest recorded Mola caught was about 5,000 pounds, even though they're usually closer to around 2,000 pounds. They are about 8 by 5 feet in size. They are vertically about 8 feet, so from the top to the bottom, and they are about 6 feet long, so from their mouth to their tail. Again, they usually weigh around 2,000 pounds. You'll see in the picture here that the Mola's mouth is open. They actually have fused jaws. I'm sorry, I messed that up there. It's not teeth, fused jaws. So their mouths are always open, which helps them catch some of their favorite food, which are jellyfish, even though they will also eat other things in the water, other gelatinous things like salps, as well as some squid and eel larvae at depths, at deeper depths. The Mola is one of the best egg producers on the planet. They have been recorded to produce more eggs than any other vertebrate on the planet. In one hatch, they can send out 300 million eggs. Most of the other fish that we're observing here today only lay in the few million eggs. So it's a really large number of eggs that they can lay. When they do, when the eggs are successful in hatching, they look like this right here. This is a larval Mola. They start off really small, and you'll see they kind of look like a star. And this is a good example because they show us that they are related to the pufferfish as well. Mola eventually will lose most of those spikes there, obviously, as you can see from the first picture that we showed you. And then they will be able to swim by flapping their dorsal and anal fins and using their caudal fin as a rudder. Caudal fin, again, is a tail fin. As I mentioned before, Mola deal with a lot of parasites. So you can see in the picture here, there's little patches. It's a very big fish, so there's a lot of surface area and opportunity for things to grasp onto the Mola. One example is a copepod that buries its head inside of the Mola's flesh. and then we'll use the mola as a host so that it can lay its eggs. I have a little short video here showing you some other creatures that take advantage of the ocean sunfish.
Parasites. Sunfish can be infested with some 40 different kinds. In the marine world, don't try to remove them yourself. Seek kelp. These beds of floating kelp are home to the half-moon fish, who will gladly take care of the problem. Weird? Maybe, but it's just what the doctor ordered. Even in the wild, though, you'll still have to wait for your appointment. The sunfish float in line until it's their turn. Then they flop on their sides to be tended to. The cleaner fish are thorough, but some parasites are beyond even them. So the sunfish seeks out a specialist. A seagull. The gull surgically hacks into the sunfish's flesh. And snaps up the last remaining holdouts. Finally free and clear, the sunfish can go back to feeding.
So again, you can just see that the parasites are not just eaten by things in the water, but by our birds. And the ocean sunfish, again, is getting its name because it is coming up to the surface so often to get rid of those parasites and to get warm. It was often thought that the sunfish just sat near the surface, but they have attached trackers. I think it was even a GoPro to a sunfish, and they've been recorded going down to some deeper depths to eat those jellies and eel larvae. I think it was around 600 feet they've been diving down to, so they can go down pretty far.
Parasites. Parasites.
Not going to watch that again. The Mola actually is impacted by fishing quite a bit. Not that people are trying to fish for the sunfish, but by bycatch, just because of where they live in the water column and their inability to really swim strongly against currents. They have been pretty impacted by that bycatch over the last 30 years or decades. Another great fish is the Atlantic bluefin tuna, which we're going to use for our art project in a little bit here. The bluefin tuna is one of the fastest swimmers in the ocean. It can get to speeds of around 40 miles an hour. They are also the largest fish in the mackerel family. They grow up to be hundreds of pounds and more than 6 feet long. They are a very unique fish because they are actually warm-blooded. And they start off their life about the size of one of our eyelashes. And they grow pretty quickly. And because they start off so small, they eat many different things throughout their life. So when they're younger, they're eating tiny zooplankton, but when they get to their adult stages, they are eating other fish and invertebrates in the water column. Their torpedo shape or streamlined shape helps them swim at those incredible speeds. They can accelerate just as fast as like race cars. They have really unique adaptations to be able to have bursting speed. And a lot of that is thanks to the warm blood. They have a unique vessel structure that we call a countercurrent exchanger. And that is what is helping them keep their blood warm. And it's also allowing them to have better vision, which is allowing them to be a better hunter and able to eat. Like I said, they have their warm blood. Unlike some other fish and similar to some shark species, the bluefin tuna has to constantly swim to be able to breathe. So it always needs water moving through its gills to be able to breathe. So they can't stop or they will not be able to breathe. The Atlantic bluefin tuna is highly sought after as a fish for our restaurants and sushi. Every year, the first fish sold in Japan goes for really record numbers of record dollar amounts. There was a fish in 2012 that was just under 600 pounds that was sold for $736,000. That is about $1,200 a pound. And that is pretty common. In January, the first fish of this species sold is always really pricey. However, per pound, this is probably the most expensive fish in the world due to its delicacy in tuna. But because of that, it is also endangered. They are highly fished, overfished. There are some stocks that are doing better thanks to some recovery efforts from international and national organizations, but we do need to think about what we eat and making sure that the fish that we enjoy are being sustainably caught or harvested. One reason that this species is harder to protect is because it is highly migratory. As you can see on the map here, there are two main species within, or subspecies within the Atlantic Ocean. We have the species that's on the coast of the United States, and then we have the Mediterranean subspecies as well. But you can see that they are traveling all around the Atlantic Ocean, which makes it harder to say exactly which nation the species falls into and whose quotas are protecting them. So we can definitely do better in protecting this species. And we're going to learn a little bit more about them at the end of the presentation when we talk about our fish prints. So we had both the largest fish and largest bony fish that I've shown you. This is the Pacific halibut, which is the largest flatfish in the world. They are found in coastal waters on the west coast of the United States, from Santa Barbara up through Alaska, even though they are more prominent in the colder northern waters. They are a little bit more streamlined than other flatfish in the flounder family, especially. They can get up to about 8 feet long and 5 feet wide, but that keeps them more streamlined than other flatfish, which tend to be a little more round. This is a right eye flounder, so they're in the flounder family, which means both of their eyes are on the right side of their head. That is a unique trait for flatfish. You will see in the picture here, though, even though their eyes both evolved to come over to the same side, their jaws do not. So they're eating from left to right instead of top to bottom. And it does take about 6 months for those eyes to migrate over to the same side. So they have similar larval stages to other fish like salmon, but are at about 6 months that eye will migrate over to the right side of its body. Pacific halibut have a lot of the counter shading that we talked about before. Their underside is much lighter than their top sides, which are used as camouflage for the halibut to sit on the bottom of the ocean. They are flatfish, so they are benthic fish near the bottom, which means that they're eating a lot of crustaceans as well. But they have been found to have species such as cod and other things too. So they will eat fish, but they do tend to eat crustaceans quite often. And the halibut is highly desirable, just like our bluefin tuna, but the Pacific halibut has been much more sustainable over the years. The Atlantic halibut had some issues in the past. It is also very similar to the Atlantic halibut, but the Pacific halibut is a little bit larger. And for a while, they thought they might be the same species because they are so similar, but they are different. So we had a flatfish and a bony fish and a cartilage fish. I also wanted to show you a billed fish. The swordfish is my favorite of the billed fish. It gets its name from the long sword-like bill that comes out of its head. once a swordfish gets to its maturity, it actually doesn't have any teeth. So it's believed that that bill is used to stun prey so that they can swallow them whole. So they're going to swim with a side-to-side motion of their head, being able to knock that prey unconscious. Swordfish are found all around the world, but mostly in warmer waters. And they are migratory fish, just like our tuna. If left alone, these swordfish can get giant, up over 14 feet and close to 1,400 pounds. But typically when they're caught in the Pacific, they're between 47 and 75 inches and around 300 pounds in the Pacific. The Pacific swordfish are larger than the Atlantic swordfish, Mediterranean swordfish. But unfortunately, most of the swordfish that are caught in the North Atlantic near us at OPAC, they're usually juveniles and they weigh between 50 and 200 pounds. This has led to a decline in swordfish populations. They are still considered sustainable by most organizations, but that wasn't the case for a while because there weren't regulations on size of fish being caught. And again, most of the population in the North Atlantic are juveniles when caught. Unique adaptation for the swordfish, you'll see that it has a really large eye. Behind that eye, they have like a brain heater. It's a way for them to regulate the temperature of their brains so that they can do deep dives for their food. So they're not as warm-blooded as a tuna, but they can control the temperature of their brain so that it's not rapidly cooling and heating as they move up and down in the water column. And again, the adults do not have scales or teeth. Those evolve out as they get older. And you'll see that the little larvae of our swordfish here, they do have teeth as well as scales, but as they grow, they lose both of those. You'll also see that the younger swordfish has a much larger dorsal fin. All right, so we also have the oarfish, which is going to be the last fish I'm going to talk about for today. I have linked a really fun video about the oarfish to our resources page. This is a fish that if you were a sailor in the 17th, 18th century and you were to see an oarfish, this is definitely where our serpent legends have come from. They can be up to around 36 feet in some recorded cases, even though they're usually only around 10 feet, which is still a large fish. They are long and flat, kind of eel-like, and they're usually found at around depths of 200 meters, even though they have been recorded much deeper than that, down to thousands of meters deep. They are unique in the way that they swim and eat. They will go vertically and use their dorsal fin to keep them in place, so kind of like treading water if you were a human. And when they're in place, they use their mouths to suck in larger zooplankton because they are toothless. So they are filter feeders. So that video that I have shows some really good footage of an oarfish doing the vertical motion and feeding. This is a pretty rare species to find, but I thought it was fun to note just because it is so large. The first time we saw this was in 2001 on camera. They do sometimes wash up on shore so that we can get samples of them, but we are still learning a lot about this fish. It's just a unique big fish in the ocean. Fish are incredibly important to humans. There's about 4.3 billion people that rely on seafood for their protein intake, and about 10% of the world relies on fisheries for their livelihood. And about 1 billion of the 4.3 billion rely on seafood as their main source of protein. So fishery were to stop, or fish species were to go extinct, it could dramatically impact not just livelihoods, but food intake in many parts of the world. Globally, more than 250 million people depend directly on fisheries. So not just from actual fishing, but from aquaculture techniques, as well as the chains of businesses that rely on fishing, whether it be restaurants, ice producers, shipping, you name it. And fish also play an important role in our nutrient cycles. So they're eating a lot of smaller creatures, whether it's smaller fish, crustaceans, jellies, zooplankton in many cases for the fish that we learned about today. All of those animals have a lot of nutrients, which then ends up in the tissues of our fish, which if the fish is to get caught, we can take in as nutrients for ourselves. But if the fish dies, this can be recycled back into the environment. Fish are moving, so they are transporting these nutrients to different ecosystems. And they also excrete these nutrients back into the environment through their natural cycles. And it's also important to note that with the over 20,000 species of fish that are in the ocean, coming in all different sizes, shapes, forms in the classes that we've learned about today, about 90% of them are overfished or fully fished as of 2016. So we have done, I would say, quite a bit of damage to the fisheries of the world, and it's our responsibility to better in our practices of fishing. Obviously, we need to fish for economics and sustainability of food populations, but we need to be better about the techniques that we use to do that, as well as being more cautious of where our food is coming from, whether it's sustainable to bring it to our plate as well. So try and eat local if you can. I have put a link to Fish Watch on our resources page as well, so you can see if the fish that are in your area are sustainable, and which fish are better to be eating. And in the words of one of my favorite oceanographers, Dr. Sylvia Earle, she always says, no blue, no green. So we really need to take care of our blue planet. It is over 70% ocean, and that can start with our fisheries. All right, so I want to show you how to do some bluefin tuna sponge art. We love to upcycle materials. We try not to use any plastic materials at OPAC. We try our best when we're using new materials to use biodegradable art supplies, so that if we lose our art project or eventually we throw out our art project, it's not going to hurt the ocean. In today's example, we're going to use an upcycled item, being the sponge. So if you have an old sponge, this is a great way to give it another life. I'm gonna stop my screen share here and move my computer so I can walk you through this art project. Just give me 2 seconds here to move my computer so that you can see what I'm doing. So we are going to be using the bluefin tuna as our fish print. So on our website, I have linked an outline to a bluefin tuna for you, and you can go onto our website and scale your bluefin tuna down to the size of a leftover sponge that you have, or the sponge that you want to use for this art project. Not saying you can't use new sponges, but it's again a good way to upcycle some old products in your house. So you can go again on our website. There is a printout of the bluefin tuna. You can scale that down to the size of your sponge. You want to print that out. You want to trace. You want to cut out your tuna outline and then trace that onto your sponge. And then you want to cut out your tuna from that sponge. And then once you're to this point, you can either put on the video here or go to our worksheet on our website and learn how to make the actual art project. I would recommend putting down some newspaper or recycled paper bags or a tablecloth when you're doing this so that you don't get paint on anything. I am using a dark blue, a light blue, and a light yellow for this art project. You can also use whites and blacks to make the colors lighter and darker. If you don't have certain colors, you can use whatever colors you want. I picked these colors because they are closer to the picture that I was going off of for our bluefin. When you are cutting out your tuna sponge, don't get rid of the excess pieces. They can also be used to design the landscape or the background of this art project or future art projects. We really like to use sponge because it gives really nice texture to the art projects that you're doing. So don't throw those out. You're going to want a paper plate or some sort of palette to put your paint on. And then just some regular paper or canvas to put your fish print onto once we have the sponge full of paint. So I'm just going to move over my recycled paper bag here. Unfortunately, we're not allowed to be bringing our reusable bags to the supermarket right now. So I have some extra paper bags. I'm gonna put this down here so you can see what I'm doing. All right, so I have got my palette. I've got my canvas here. So what you're gonna wanna do with your paints, you're gonna want to make lines with your paint. And you're going to want to keep them about 1 inch apart. So you just want to do some thin lines of paint on your palette here. You can do them in the order that you would like them to be on the fish. You do want to keep them separate when you're pouring the paints onto the palette. I'll show you why in one moment here. Yeah, about 3/4 of an inch to 1 inch apart. Once you have your lines of paint, we're going to take out that sponge that we have, and you're going to dip that into the lines of paint. If you refer back to the picture I had here, our tuna does have some counter shading, so there are different layers of color. So we want to try when we are putting our fish into our paint to try and keep some layers, but the blending is also artistically pretty cool. But we're going to try and keep it as close to the fish as the anatomy of the fish as we can. So you're going to take your sponge and you're going to start to gather some of that paint. And when you're doing that, you can start to blend the colors together here. So you can see I'm just lightly touching the sponge down, and I'm trying to make sure that it's fully saturated with paint. So you can check. You want to make sure that all of the fins are getting some paint on them, and the tail I found when I was first doing this was a little bit harder to get some paint on. So you want to make sure you get that. And once it looks like you have all that paint, you're going to transfer your sponge to your canvas, and you want to make sure that you're pressing down evenly on your fish and make sure that you're including all of the fins so that the paint is being transferred to your canvas. I do find it helpful to add just a dab of water to the sponge too, which will help the paint transfer. So once we've pushed evenly across our sponge here, I'm just going to lift up, and we can save this for later. We can do more, but what we're going to be left with is our nice fish print here. So probably could have pushed a little bit harder on the top side, but it's just a really nice way to use some leftover materials from your house to make some artwork. What you can do is dip your sponge into your canvas and make more fish. You can experiment with different colors, and you can also use like I said, the smaller pieces of sponge to decorate around, so you can try and make textured ocean bottom, so the benthos. You can design the background for your fish. You can, if you have larger pieces of sponge, make other species, other ocean species. And I encourage you to share what you make with us. Just one way that we can advocate for the ocean is by making some wonderful art to share with other people, because art is a really easy way to tell a story about the ocean. And if you are able to join us for more OPAC webinars or workshops in the future, you will definitely be doing some more artwork with us. Hope that you were able to see that, and if you have any questions about it, please shoot us an email. You can also ask us questions on Facebook. Sorry, I want to just pull up one more thing here for you before I sign out. So hope you enjoyed that activity. There are some things that you can do from home to keep advocating for the ocean. Like I said earlier, we can eat sustainable seafood when it's safe to do so. Conduct a local beach cleanup. Tomorrow is the 50th anniversary of Earth Day, so maybe do a cleanup in your yard. I know where I live, there's always trash on the road, so if it's safe to do so, clean up your earth. Skip the single-use plastics, because they are one of the largest producers of marine debris in the ocean, and be the voice the ocean needs, because it can't speak up for itself. We have to do it for it. The animals do care. We've noticed with some of our social distancing over the past few weeks that species are returning to places that they haven't been in a while. The ocean is quieter from less ship traffic. So our marine mammals and our other ocean creatures really do appreciate it. There is a link to the worksheet that will explain the art project that we just did on our website. You can also submit some of your ocean art to some art contests. Some of those deadlines are coming up, so check those out. I linked the Seafood Watch from Monterey Bay Aquarium to our website, so you can look at some sustainable seafood options. I have linked an experiment to make a swim bladder of your own in your bathtub at home. And then I've linked some individual links to this fish that we talked about today. So some more follow-up for you on our website. I will take a moment to answer any questions for you if you have them at this time. See the question, what is the most endangered fish? Truthfully, I think that's going to depend on who you talk to. There are species on our planet always going extinct, but we have shown that, for instance, in New England, we had a really dramatic decline in the cod fishery, and with strict quotas and regulations, we are starting to see a rebound in cod. So even though there are fish that are extremely endangered, and as I said, there are over 20,000 species of fish, so as I'm not a fishery scientist, so I cannot tell you exactly if there's an individual fish that is more important than the other. As I also mentioned, 90% of our fish are being overfished, so it is important that we're caring about all of them. But check out that Seafood Watch, so we make sure that we're all being responsible ocean advocates. I don't think any fish has come back from extinction, because once you are extinct, you are no longer here with us. So we need to be good conservationists And when we do notice that our fish are being overfished and are endangered, we need to protect them. Any other questions for us right now? So I see, what is the deepest part of the ocean? That would be our hadal zone of the ocean. This is more than, I believe, 6,000 meters is the beginning of our hadal zone. So extremely deep, where we have pressures that are similar to Jupiter. Leave our question panel up here for about another 30 seconds if I don't see any questions coming in. Out of the 3 categories of fish, which category is the basking shark in? The basking shark is in the cartilage fish. That is where all of our sharks and rays and skates are. And when I said there are 3 categories of fish, those are just the 3 big groups. You can categorize fish in many different ways, but those are the 3 big orders of our fish. That's a good question. Any other questions here for us? All right, thank you so much for joining us again. If you've joined us in the past, just remind you again to please like us on our social media platforms. It's the best way to stay up to date on all of our program offerings. We are going to have some more stuff going on over the next few weeks here on our website. For Earth Day tomorrow, I just want to leave you with the message of it. It starts with knowing. So please continue to learn about our ocean, because the more you know, the more you can advocate for the ocean and the more you can do to protect it. Thank you so much for joining us again and for your continued support. And I look forward to seeing everybody soon.